Okay, this section is about parabolas and graphing parabolas in vertex form. So this one reads, identify the vertex, the axis of symmetry, and the points corresponding to P and Q. So the vertex of a parabola are these spots right here. And they are called, this one is a minimum because there's a minimum point right here. So this one, the vertex, looks like the scale is going up by 1. So this vertex is going to be 0, -1. The axis of symmetry is a line of symmetry. So this red line is a line of symmetry. It's a vertical line. So it's going to be x equals, and x has to equal 0. So it's x equals 0. And then the corresponding parts for P and Q. So if you look at Q, and this is your line of symmetry, which point on the opposite side is Q? So what I'm going to do is, if Q is 1 unit over right here, Q prime is going to be right here. So this point is at -1, 0. And if you have P is on the left hand side, P prime is going to be directly over here. So P prime is at +2, 3. So over here, the vertex is actually already labeled as the P. So the vertex is at -2, 1. The line of symmetry is this red line. The red line is x equals -2. And then P prime is going to be on the line. So P prime is, or the point that's right there. So the point is -2, 1. And then if Q is right here, Q prime is going to be over here. So Q prime is going to be at 1, 2, 3, 4, -4, 0. And if I look at this parabola, I didn't draw that very well, but it's kind of hard to read. So the vertex is at 1, -4. And the axis of symmetry is the equation x equals 1. And then P is at -1, -1. So P prime is going to be the exact same distance apart. So if this distance is 2 units, then I'm going to go over 2 units right here. So this unit would be 3, -1. That's P prime. And then if Q is 0, -3 1/4, then this one's going to be over 1 from this spot. So if it's over, so if these two right here are over 1, then this has been from the y-axis, it has went over 2. So the x value is going to be, so Q prime, the x value is going to be 2, and you're still down 3 1/4. Okay, so for this part right here, identify the vertex, the y-intercept, and the axis of symmetry. We're going to graph it too. It's hard to see. I'm going to go with, I can't really tell, but I'm going to say that's a 1. I don't know what I put on the worksheet, but so if that's the vertex, or if this is in vertex form right here, this is a quadratic in vertex form. So from here you can get the vertex. The vertex is opposite, or -1, and then 4. So I'm going to make a dot at -1, 4. Now the y-intercept, so I did the vertex, the y-intercept is set y equal to 0. So, or set x equal to 0. So if I set x equal to 0, I'm going to plug in 0 plus 1 squared plus 4. So 2 times 1 squared plus 4. So 2 times 1 plus 4, so it's 6. So if I go over to 0, 6, it's right here. So if this is my vertex, then my axis of symmetry goes up like this. So, I can make a table. If you're not sure what to do, you can always make a table. Plug in values for x and y, such as, I usually put the vertex in the middle, and then pick numbers that are less. Oops, I went the other way. Pick numbers that are less and then greater, and fill that in to get 5 points. But right here, I'm going to use symmetry. If I know that these 2 points right here are on the parabola, and this is my line of symmetry, that means that this point has to be over here too, because these two are equidistant. So I can draw my parabola just like this. And then I'm done. Oh, I didn't write my equation for the axis symmetry. So the equation is x equals -1. So use symmetry to graph your parabolas. And then 14, my vertex is at +5. There's nothing right here, so it's 0. So I go over to 5, 0 right here. And now I'm going to find the y-intercept. So the y-intercept is set x equal to 0. So 0 minus 5 squared. So that's 25. Great, now I need to rethink my scale here. Because I have a y-intercept of 25. So I'm going to go up by 5s then. So 5, 10, 15, 20, 25, and then 5, 10, 15. So now I have 5, 0 is my y-intercept. 25 is my vertex. 25 is my y-intercept. So I'm going to draw my line of symmetry, my axis of symmetry. The equation's x equals 5. And now I can put this point over here because it's symmetric. And I can draw my curvy parabola. So you need to be able to graph a parabola in vertex form and standard form. So, and also down here, to solve quadratics. There's all different ways to solve quadratics. You can always use the quadratic formula. That always works. So these, I'm going to start out by solving by factoring. I'm going to factor first. See if I can factor. So when you solve by factoring, you want to have one side equal to 0. And I do. So now I'm going to factor out over here on the left hand side. I'm going to check to see if I can factor. So what I see both in common in here is that they both have an x. So I'm going to factor out an x of both terms. Now I'm going to use the zero product property. So now I have two factors that when I multiply them I get 0. That means that x has to equal 0 and x minus 7 equals 0. So I solve each of these for x. So this one I can't really solve, but if I solve this one I get 7. So this is way simpler than doing the quadratic formula. I was trying to solve first by factoring. So now I'm going to try to solve this one by factoring. Okay, so if I see I have one side equal to 0, then I always try the greatest common factor first. So is there something that I can factor out of all three terms? They all three don't have x. So, but I can think of when you have three terms, it's a binomial, and you can factor it into two binomials. Let's check that. So what you want to do is factors of -8. So what are two numbers that multiply to be -8 and then add to be 2? So think of factors of 8 or -8. I'll list them out. So you have -1 and 8, 1 and -8, 4 and 2, +4 and -2. So which of these adds up to be 2? It's this one right here. So your factor is going to be x plus 4, x minus 2. Now you have factors that are equal to 0, so use the zero product property. So x plus 4 equals 0 and x minus 2 equals 0. So x equals -4 and x equals 2 is the answer. So solving by factoring works if you have one side equal to 0 and you can factor it. So this one, I don't have one side equal to 0. And this is already factored. So what you can do is solving by square root. So I can take the square root of both of these sides. So when I take the square root of this, these are inverses so they cancel out. So I get x plus 3 equals, the square root of 9 is 3. Because I'm squaring this, and this is equal to a positive number, technically x plus 3 squared could actually be equal to a negative number too. That would work. Because you could square negative, if this was negative 3 and you squared it, you would still get 9. So you have to make sure that when you square root both sides, you have to do the positive and the negative. So I'm going to subtract 3, so x equals 0, and I'm subtract 3 right here, x equals negative 6. So let's check it. So if you do 0 plus 3 and you square it, you get 9. That's true. If you do negative 6 plus 3 and you square it, you do get 9. That's true because this will be negative 3 squared, and that's going to be a positive because it's in parentheses. So it works. So here are my two solutions. So if you think about the solutions of a parabola, it's where it crosses the x-axis. So this parabola opens up because this is positive, and the x-intercepts are 0 and 7. So it looks something like this. This parabola opens up because it's positive, and it has roots at negative 4 and 2. And a y-intercept is of negative 8, so it looks something like this. This parabola opens up, and it has roots at 0 and negative 6, something like this. So your solutions are where it crosses the x-axis. So you could have problems that don't have solutions, or real solutions.